Hello students, welcome to the lecture of signals and system. The topic for the lecture is the continuous time convolution integral, and basically we are discussing the properties of the convolution. This is the content of the lecture. So first, summary of the previous lecture. So in the previous lecture we have discussed the example of the radar range measurement, how convolution is useful to determine the round trip delay, and from that delay how we can measure the distance of the object from the radar. After that we have discussed the some useful properties of the convolution, and we also derived the properties. So basically we have discussed the commutative properties, associative properties, and distributive properties of the convolutions. So basically in a using that properties you can uh, use this property and you can calculate the convolution of the signals. And then after we discuss the interconnections of the LTI system, where we discuss the if the two systems connected in cascade, what is the overall impulse response of the system, and if the two systems connected parallel, what is the impulse response of the system. So basically in a parallel, the overall impulse response basically sum of the parallel LTI systems, and basically in the cascade it is the convolution between the LTI systems. So that is the summary of the previous lecture. For today's session we continue with the properties. So some more properties of the convolution, that is based on the duration and the areas of the signals. The properties based on the linearity, the properties based on the time invariance, and the time scaling property for the convolutions. And we'll solve some examples based on all the properties. So basically this property helps to calculate the convolution. So you can if you know the some convolution of x and h, and let us take if the any signal is delay by some very period, that is let us take x of t is delay by x of t minus alpha. So what is the resultant effect in the output? So we can use a time invariance property, and we can find out the what is the output of the LTI system if any signal is delayed, right? So basically these properties help to find out the convolutions, right? So I think that's all for the today's lecture. So thank you.